Hello, welcome to section 6.4. We're talking about general strategy for factoring polynomials. So up to this point, we've talked about the different types of factoring, and now we're going to come up with the entire, like an entire cohesive theory, like when do I know what to do, right? If I'm presented with a polynomial, what do I do with it? Okay, well, you're in luck because this is what you do, okay? So when you first look at it, you ask yourself, all right, is there a GCF? Okay, so that's the first thing. Anytime you look at a polynomial you're about to factor, is there a greatest common factor? And then you factor that out. So after that fact, after you factor out the polynomial, the greatest common factor, you ask yourself, okay, is it a binomial, a trinomial, or does it have more than 3 terms? So you count the number of terms. If there's 2, it could be one of the following possibilities. Okay, so let's suppose that after you factored out your GCF, you realize there are 2 terms. Now then you ask yourself, okay, there's 2 terms, right? So let's say it's something like, you factored out a 2x, and then you have something like 4x squared minus 1. Okay, so inside you have 2 terms. So it could either be a difference of squares, right? So if it's 2 squares being subtracted, then you follow this pattern. It could be a sum of squares. If it's a sum of squares, it's not factorable, so you stop. If it's a sum of cubes or a difference of cubes, these are the formulas for that. Now, what if it's not a binomial, but it's a trinomial? So it's either in the form ax squared plus, it's the common form is ax squared plus bx plus c. But if a is 1 and it looks like this, then we can factor using the factors of c such that when you add it together, it equals the middle, right? And then the other one, if a and c are squares, right? If it's a perfect square trinomial, we can follow this pattern for factoring. Or finally, we could use AC method if it's neither, right? And then if it's more than 3 terms, we factor by grouping, okay? Right, so if it's like, and then we're going to do some examples from here on out. All right, so let's go ahead and let's get factoring here. So let me just show you what I just said in text. So basically, the general strategy is step 1, is there a GCF? If so, factor it out. Is it binomial, trinomial, or are there more than 3 terms? If it's a binomial, is it a sum of squares? Then sum of squares do not factor. And you stop, excuse me. If it's a sum of cubes, you use the sum of cubes formula. If it's a difference of squares, it's a plus b, a minus b. If it's a difference of cubes, you do that pattern. If it's a trinomial, you ask yourself, is it the form x squared plus bx plus c? Undo FOIL, or just use what I said, factors of c that added together give you b. If it's the form ax squared plus bx plus c. If it's a perfect square trinomial, you can go ahead and use that pattern, or otherwise you can use the AC method. I don't really recommend trial and error unless you're very good at mental math, in which case by all means go for it. And it has more than 3 terms, use factor by grouping, right? Remember, we're going to get into it. So then finally check and make sure that all the factors are factored completely. And then if you have time, you can multiply it back out and then see if you get what you started with, okay? So let's go ahead and do some examples. Let's factor this completely. So first step, we have 7x cubed minus 21x squared minus 70x. What's the GCF here? The GCF here would be 7x. So we factor out the GCF, 7x. What are we left with? We're left with x squared minus 3x minus 10, okay? Now inside here, so we kind of ignore the GCF now, but it's still there. It's kind of like in the back of our minds, like when your mom tells you to go clean your room and then you kind of just ignore it for a long time. Okay, so basically you take the last term, which is a negative 10, and you ask yourself, okay, what are the factors of negative 10 that when combined together, it's equal to negative 3? So that would be negative 5 and a positive 2, right? So then once we have these magical numbers, remember the 7x is still there, but we can rewrite this trinomial as x minus 5, x plus 2, okay? And then that's completely factored because we can't, obviously, these are all linear factors. We can't factor anymore. Okay, let's go ahead and do the next one. So here we have 24y squared minus 150. So the question is, what can we factor out here of 24y squared? Is 150 divisible by 24? So you tell me. It's not. So what else do we have here? Do we have, obviously we can take out a 2, but can we take out more? So if you really, let's see, not 4. Let's see, 150 divided by 2 would be, can we do, let's see, 3? We could do 3. Could we do 6? 150 times, we could do 6. So let's go ahead and factor out a GCF of 6. So if we factor out GCF of 6, okay, so there's a couple, just to recall, how did I find the GCF of 6? I just kept dividing by even numbers until I could get, because these are both even, so I started at 2, and then I went up to 4, then I went up to 6, and it worked. So, because it's also divisible by 3, so if something's divisible by 2 and by 3, it's also divisible by 6. Okay, so taking out a 6 leaves me with 4y squared minus 25. So what's this now? This is actually a difference of 2 perfect squares, okay? So then that becomes 2y plus 5, 2y minus 5, and we're done. Okay, because you can't factor that anymore. All right, let's do a few more. We have here 9a squared plus 12ab plus, 4a squared minus 12ab plus 9b squared. So this is a perfect square trinomial because this is 2a squared, this is 3b squared, this is minus, and then 2 times 2a times 3b will give me 12ab, so it fits. So then I can go ahead and factor this into 2a minus 3b parentheses squared. Okay? And that's because we recognized it was a perfect square trinomial. Okay, so let's go ahead and do one more. So is there a GCF here? Yes. So let's go ahead and take that out. I think 3xy squared. If I take that out, what am I left with? I'm left with 4x squared plus 25. And then after, so can I factor this anymore? You might think, well, this is a perfect square, this is a perfect square, so go ahead. But no, we cannot, because this is a sum. It's not a difference. It's not a difference. It's not a minus, okay? So this means that this is not factorable, and we leave it as is. This 4x plus 25 is not factorable, okay? So that's it. That's our answer. Okay, let's do a few more. How about 24x cubed plus 81y cubed? Can I factor out a 3 here? So 3, and that leaves me with 8x cubed plus 27y cubed. Now what's interesting is, yes, this is a sum, but this is a cube. And are these perfect cubes? They are. So I can actually think of this as 3 times 2x cubed plus 3y cubed. Okay? And then that becomes the sum of 2 cubes. Remember how to factor the sum of 2 cubes? It's a plus b, a squared minus ab plus b squared. Okay, that's the formula. So since our a is 2x, our b is 3y, and don't forget the 3 on the outside, we get a plus b, 2x plus 3y, a squared. So I'm just going to write it 2x squared minus 2x times 3y plus 3y quantity squared. So simplifying that, we leave the 3 on the outside. We get 2x plus 3y. And then here we have 2x squared becomes 4x squared minus, and then this is 6xy plus 9y squared, and we're done. Okay, not too terrible. Okay, let's go ahead and do another one. We have here 3x to the power 5y, 48 minus 48xy. So common GCF is a 3xy, leaving us with an x to the fourth power minus, and then 48 divided by 3 is 16. Right. So now what? This is a difference of squares, actually, because we can think of this as, it would be 3xy on the outside, x squared minus 4 squared. Okay, so if that's the case, I'm going to start over here. 3xy, so it's going to be x squared plus 4, x squared minus 4. Now, am I done? No, this is another perfect square. So it becomes 3xy on the outside, x squared plus 4, that's not factorable because there's a plus sign. And then x squared minus 4 factors into x plus 2, x minus 2. Okay, and that's that one. Okay, lastly, let's do one more. Here we have how many terms? 1, 2, 3, 4 terms. So we can't use difference of squares. We can't use any of that. Sometimes, not always, sometimes if there's 4 terms, one of the terms is a trinomial that we can factor, and then the other one is something else, and then that itself factors. But for now, let's try factoring by grouping here. So ignoring the second two, but looking at the first 2 terms only, my GCF for these first 2 terms is a 4x. So what does that leave me with? That leaves me with x plus 2b. Now here, these are both negative, and so I can take out a negative 4 from both of these terms and an a. So negative 4a, and that leaves me with x plus, what do you know, 2b. To be or not to be. So now I notice that these two are exactly the same. So I'm going to factor that out. So x plus 2b, and then what's left is this 4x minus 4a. Oh, but see here, there's another GCF right here. That has a GCF of 4. We probably should have taken it out way back here. So see what happens. If you miss that step, you will see the GCF again, and then you can pull it out. So here I can factor out a 4. So finally, I can write that in front. 4, x plus 2b, and then x minus a. And there you go. Okay, that's it for this section. Good luck, happy studying, and I will see you in the next video.